Hey guys, so welcome again to our next session with Peter the Tender about Azure Loves Terraform Loves Azure. So I'll let Peter introduce himself. Welcome, Peter.
Hey, Andrea and everyone here in the session. Good afternoon. I hope you already had a pretty good collab day so far, and I'm going to try to stick to the same good feeling and talking a little bit about Terraform, how you can use it as your, I would say, future infrastructure as code to make your Azure deployments a lot more straightforward. So let's see if we can get our PowerPoints up and running here. There we go. Should be good for now. So again, my name is Peter, and I'm going to try to walk you through some basics around Terraform, starting a little bit with what infrastructure as code is, and hopefully walking you through most of the topic with typical in my sessions using quite a lot of demos. I'm not using my camera for now since I'm on a shared internet connection. I lost internet at home a couple of days ago, and I'm quite limited on my bandwidth capacity, but streaming shouldn't be a problem as long as I'm not using camera. I might open it up all the way at the end for the Q&A timing we have, so you at least know that it's a live session, that it's not a bot talking to you about the great cool stuff. So let's get started here, and I'm quite sure you all know about the purpose of this slide, but nevertheless, it is still quite important to thank our sponsors here for making today possible, together with obviously the technical team supporting the conference. But as probably a lot of you know, without the sponsors, this event wouldn't even be possible. So reach out, talk to them, maybe still today or later, somewhere next week. Reach out to them on social media, and again, once more, thank them for supporting us. Let me walk you through the core topics in the next 55 to 60 minute session. So I'll start with a quick overview of infrastructure as code and how you can use Azure templates, which out of Microsoft is still, I would say, the go-to solution to make your Azure deployments running in a smoother, faster, more optimized way. Now, next to a quick introduction on ARM templates, I'm obviously going to focus on Terraform and why Terraform could be a better solution depending on some characteristics. That's obviously the main idea what I'll walk you through. From you know what Terraform is and how it can be used in your environment, I'm going to walk you through the core Terraform basics, not meaning that it's super basic, but really like what is the Terraform concept that actually makes it quite useful for Azure deployments. And then the rest of the session will be a combination of all the nice things from Terraform together with all the nice things from Azure that some of you, I guess, already know about. And last, closing with a little bit on using Terraform in a DevOps mindset, where I'm going to use Azure DevOps, but in reality, it doesn't need to be Azure DevOps, but that's more for towards the end of the session. I have Q&A at the end, but I'm checking the chat box every now and then, but we should have about 10-15 minutes or maybe a little bit more, depending how smooth all the demos are working and how many questions we have. So that's about it. A little bit about myself. So Peter, based out of Belgium, and before COVID, I was traveling about 90% of my time the last couple of years across the globe, providing Azure readiness workshops to larger customers and partners. And then last year, somewhere September, I joined Microsoft as an internal full-time employee in Microsoft Learning and providing Azure technical training workshops. So basically the same job that I did before, but this time as a Microsoft FT. Before I joined Microsoft, I was an Azure MVP for 5 years. And before the Azure MVP, I was MVP on the Windows IT Pro platform. In a little bit of free time that I have, I'm still loyal to my community background. Main reason why I'm talking to you here today. but also keeping myself entertained by writing technical white papers and books on the Azure subject. Feel free to stay in touch. Send me an email, reach out on Twitter, Facebook, LinkedIn, any place you want. I'm not on Snapchat, I'm not on Instagram, but outside of that, you should be able to find me pretty much all over the place. So with that, let's get started and giving you a quick overview of Azure automated deployments and mainly what it means to use infrastructure as code. Using a Wikipedia official statement or official definition, infrastructure as code is the management of infrastructure components, which means storage, networking, servers, but it's not just infrastructure cloud resources. So you could also use infrastructure as code to deploy container services, to deploy application services, to deploy serverless components like Azure Functions, Logic Apps. But quite important, it's based on a descriptive model. Now, what it means is instead of just logging onto the portal or even firing off a PowerShell script or an Azure CLI bash script, you're going to move to some kind of definition file that allows you to reuse it. That would be the immutable part here, but also allowing you and guaranteeing to give you that same outcome of the deployment, what we typically describe as idempotence, which means that once you have your definition file, you test it, you deploy it, it's going to run fine. And from there, you could easily destroy resource groups, reapplying the template, and the outcome will again be the same. If something should not be providing you the same output, it typically means that, or in the backend of the platform, something has changed. Could be like a REST API version that requires you to update your template files, or obviously something could be wrong with that specific service at that moment in time, blocking you from actually deploying it. And then last, another core characteristic of infrastructure as code is lights out deployment, which obviously means that it allows you to provide full end-to-end automation. So in short, you're going to build an Azure template where Azure ARM templates are using JSON, which by itself is already quite complex. But the core idea is starting from this JSON file, you're going to interact with the different Azure resource components. And for example, creating version 5, because it literally takes a couple of attempts before your first deployment might be successful. I'm literally talking about my own examples here, where I'm going to run a dev and test resource group deployment, where I'm installing storage accounts, SQL database, web apps. Again, it's not just using infrastructure services. From there, I'm going to make some updates. So my template becomes version 0.6, where I'm going to add some additional components. And for example, moving to a staging environment. So I'm not adding components in the existing resource group. I'm reapplying my template to move to a new resource group. And from there, eventually, when everything is working fine, I'm super excited because now I'm going to reapply my staging template where it's becoming version 1. And from there, I'm going to move to a full production state. So 4 different scenarios, 4 different resource groups, started small, adding some components, typically fixing some issues in my template files and reapplying them. So that's really the core basic idea of infrastructure as code. If you've never seen an Azure template before or an Azure template deployment before, let me quickly show you what it looks like. So let's say we want to deploy a virtual machine. I'm using VS Code, probably one of the better editors to do that. And from here, the recommendation would be to install the Azure Resource Manager extension, allowing you to recognize syntax and at the same time helping you to optimize the authoring part. Now from here, if it's the first time you've seen ARM templates, come on, VS Code, stop telling me that I need to update my extensions. I'm in a live demo here, come on. So although it's not super difficult at the beginning where you define parameters, it's a little bit harder once you start looking into the resources. So for example, here, you already need to know a little bit more about Azure Resource Manager by itself, where you're going to highlight the resource provider. So up here, you need to know I'm targeting Microsoft.storage, and within the storage resource provider, I'm going to target storage accounts. You need to define the API version. You need to know about what's happening under the hood with, for example, SKUs, although we talk about sizes, and so on and so on. So the syntax itself is not always, I would say, that straightforward. From here, the deployment, I'm going to save you from deploying it for now, but what you could do is running portal-based deployment, where you can import your template file. You also have a full resource list, sample templates on GitHub. We have a couple of sample templates up here that you can easily reuse. But again, it's not about ARM templates. You're all here to learn about Terraform. Now, although again, ARM templates are the baseline for running infrastructure as code on Azure, it also comes with quite some challenges. So first of all, that JSON format, I think, is probably one of the first hurdles, where JSON by itself is fine for computers, maybe still fine for developers. But what if you're an IT pro sysadmin and you're a little bit worried about the JSON syntax because maybe you're familiar with PowerShell, maybe Bash CLI, but that JSON file is probably one of the main issues there. Next to that, the ARM template structure is quite complex. It starts with parameters, variables. That's all quite okay. But once you need to dive into the Azure resources itself, it's becoming quite complex, which means the authoring process is hard. And another one that I'm really missing is allowing for comments. So what it means is that in your ARM template, if I go back here, I literally need to go through the full template to actually figure out like what's getting deployed here. And based on some of the resources, it's a quite straightforward template. It's a virtual machine. How do I know based on the folder name? Because I called it virtual machine template. Or I could drill down and detecting that there's a storage account, network components, and so on. But imagine that you want to deploy a multi-server environment with a lot of storage components, a lot of more complex network components. Then comments would be quite convenient. Next to that, you need to run a deployment to actually validate if your deployment is successful. So there's no real testing scenario available. Now I need to be a little bit more enthusiastic, I guess, and a bit more correct, because a couple of months back, somewhere at the end of May during the Build conference, Microsoft actually announced an integration in ARM JSON files to add comments and also to run a what-if statement, allowing you to validate your deployments. But on the other side, Azure Resource Manager has been around for like 5 years and a bit, and it somehow took them 5 years to come up with those, I would say, somehow default features. Next to that, another challenge is what if your deployment is failing? So imagine you deploy your template with all Azure resources within, and halfway through there's a mistake in a naming convention where you have like a storage account name starting with a capital, which by itself out of the resource provider is not accepted, or you deploy a web app where the name is not unique across all web app names, then obviously your deployment will fail. Out of the resource provider, it's going to block you from deploying, but maybe in the meantime, you already deployed all other resources, which means you need to remove the resource group with like a pending state, or at least you need to go back to your template file, updating it, fixing it, redeploying, where luckily everything that's already been deployed will still be there, but it's still not really, I would say, admin friendly. And obviously the last one is that it's Azure native. If we look at public cloud adoption, about 74% of all interviewed customers, it was done by an external research organization, so those are not Microsoft numbers, but the world is not running on Azure alone. So about 74% is running hybrid and 82% is running multi-cloud, where hybrid means that customers are moving workloads to a public cloud environment like Azure, but also keeping a lot of resources, a lot of their traditional data center components on-prem for the next couple of months, maybe years. Or 82% of organizations are literally moving to a multi-cloud environment. Could be compliance reasons, could be data governance reasons, where Azure, although we have 61 regions all over the world, you might still be in some location where Azure is not present and maybe some other public cloud vendor will be there. So in all those situations, ARM templates are not really going to help you. And besides that, there are actually a little bit more challenges depending on specific use cases. But together with multi-cloud and some of the challenges I talked about, ARM templates, unfortunately, are not enough. Now, enough about ARM templates and moving on to the nice thing called Terraform. So what is Terraform? It's a product provided by a company called HashiCorp based out of the US, and it's allowing you for provisioning infrastructure together with application resources across private cloud, meaning on-prem Hyper-V VMware, public cloud, Azure, AWS, Google Cloud, and even integrating with external services like a managed service provider using a common workflow. By design, Terraform is multi-cloud aware, which means that everything I'm going to walk you through for Azure is also valid for other public clouds and even on-prem environments. Terraform is using a HashiCorp configuration language, technically based on Golang if you're a developer and interested how they actually came up with HCL, where you'll find out later on in some of the demos that the syntax is a lot easier than what I showed you in ARM templates. And then last, it's obviously also infrastructure as code. So everything I talked about at the beginning of the session, it's still valid, it's immutable, so you can reuse it, redeploy over and over, moving it from one environment to the other, although I'll talk about it that it's not always that easy. And from there, it's part of a larger set of overall admin multi-cloud management tools, where Terraform is the infrastructure as code component. Vault is a product out of HashiCorp, allowing you to store secrets, a little bit similar to Azure Key Vault, and again, providing you multi-cloud secret store capabilities. Packer could be another interesting one, specifically for Azure, but again, multi-cloud ready, where you can create a Packer template file to deploy or build a virtual machine image, Windows or Linux, and from there, running new deployments using Terraform or even using Azure by itself, and running new virtual machine deployments based on a Packer image tool. Why should you use Terraform? First of all, again, because it's almost like natural English. And I'll walk you through some template examples later on. And you're going to find out that it's a lot easier than the more complex JSON structure in the ARM template syntax. For some weird reason that I never really looked into, Terraform deployments are actually faster. So they're faster in starting up and they're actually faster in finishing. And one of the reasons is because they're natively targeting the cloud REST APIs. And there's no, I would say, graphical or GUI overhead like running deployments from the portal. If you would run ARM template deployments from PowerShell or Azure CLI, you're going to find out that there's not really too much difference. Terraform is also using a concept called state, and I'll talk about it a little bit more, but that's really, I would say, the additional intelligence out of the product. And Terraform also allows you to run a destroy command, which, again, coming back to the ARM challenges, when a deployment should fail, you can easily run some kind of revert and destroying any unsuccessful deployment components. A quick view on the syntax. So on the left-hand side, I have my ARM that I need to deploy an Azure storage account. So I start with this schema, the parameters, variables, and eventually the resource description, where I'm going to deploy my resource group. One of the other scenarios that's only possible since a couple of months. And last, I'm going to deploy my storage account. Where on the right-hand side, I can do the exact same thing using the HashiCorp syntax, where we're going to target the resource Azure RM, so quite easy. Resource group, where we define the name and the location, and next to that in the same definition file, we're going to deploy another resource called Azure RM storage account, again, almost plain English, and defining some of the other characteristics. Let me show you a couple of other examples. And I'm reusing my VS Code. So if, again, you've been using ARM templates for quite a while, and you're so familiar in using VS Code for the authoring part, Terraform can automatically integrate with it as well. So from here, one example where I'm deploying a resource group. So first of all, recognize I have my comment, so I can literally provide a description, one line, multiple lines, doesn't matter, how to create a resource group. Next to that, you need to become a little bit familiar with the HashiCorp language. But even if this is the first time you see this file, you can literally read out that I'm going to deploy a resource, being a resource group, targeting the Azure Resource Manager platform, and I'm providing a name and location. Now, this is quite easy because it's just a resource group. I could make it a bit more complex and mapping it with the exact same file that I have for my ARM template virtual machine deployment, where first of all, again, line 14, I'm creating a resource group where Terraform is smart enough to pick up if the resource group is already there, it's not even gonna touch it. You can add tagging, so one of the core Azure governance tools or instruments allowing you to identify what kind of environment you're gonna use it, or like a cost center, for example. Next in line 24, create virtual network, where I'm providing a name, an address space, the location, and also specifying the higher level resource group. I'm deploying a subnet. I'm creating a public IP network security group with, again, in my opinion, a quite straightforward syntax where the baseline is always the same. So you have the keyword, the parameter resource, followed by the resource type, Azure RM for Resource Manager, followed by the name of the resource, where in this case, line 80, it's network interface. Up here, and going back to, for example, the security group, it's almost the exact same naming convention. Using Azure RM underscore the name of the resource provider or the name of the resource we want to deploy. And from here, I could show you all the other details, where again, the syntax is super straightforward, a lot easier to recognize, a lot easier to read through. Now from here, we have our template file. Now, before we are actually capable of deploying it, we need to take it one step further in the basics and walking you through some of the core Terraform concepts, where Terraform by itself is also covering a concept called Terraform providers. Now, what is a provider? It's a little piece of technology. Think of a REST API or overall API interaction across different clouds. So it starts with Terraform, and imagine that we want to target the Azure platform. It means we're going to import the Azure provider. But maybe we also want to use Terraform to deploy Kubernetes environments in Azure or somewhere else. Doesn't really matter because we have native Terraform providers to allow deployments, configurations, everything you need to keep your Kubernetes environment up and running. At the same time, we have providers for AWS, for Google Cloud, and again, a lot of other technology services and providers like Veeam, like VMware, and again, a lot of other ones. So the core idea is that once you're familiar with the provider concept, you can literally start integrating with all the other components in your environment. So similar to ARM templates mapping with Terraform syntax, I can show you here the same snippet that maps the multi-cloud aspect. So on the left-hand side, I'm using AWS provider syntax. So there's a Terraform template allowing me to deploy a virtual network on AWS. That's technically called VPC, and what it looks like on the Azure side. So first of all, there's a mapping with the provider. So we start with configure the cloud provider or the on-prem service provider we want, where the syntax again is 100% identical. Meaning if you've been using Terraform for AWS and for some reason you're migrating to Azure or back to the multi-cloud concept, a lot of the Terraform syntax will be identical. Where next we have the variable in the exact same syntax in example line number 2. Next, we're going to define our virtual network definition, and last we're going to target the actual resource details. Obviously, there's no such, I would say, such thing, and it's a little bit of a wrong mindset for a lot of customers, where out of, again, the multi-cloud aspect of Terraform, there's a misconception that it is really that easy as defining one single Terraform template file and literally doing a find replace AWS with Azure RM. So that's not really the case. You still need to create multiple template files depending on the cloud backend you're using, but at least about, sometimes depending on the resources, about 85 to 90% of the syntax will look and feel identical, which by itself is obviously an interesting benefit. So how do you become familiar with the syntax? Again, like I already showed you in some of the template files, it's always following like a 3-step scenario. You start with targeting the resource provider. From there, you're going to target the resource type. So again, if you know that it's Azure RM underscore something something, depending on the service or resource type you're targeting, it's becoming super efficient. Azure RM underscore resource group, no secrets there. It's going to deploy the resource group. Azure RM underscore virtual network, it's going to deploy a virtual network. So we're really trying to reuse the naming provided by the resource provider itself or the service. And obviously it might be, again, a little bit challenging at the beginning, but once you get into that concept, it actually becomes quite straightforward. So we start with resource type, followed by the resource name. So any name you want to give it. In this case, my resource group will be the demo RG. And last, any other parameters that are specific for the resource you try to deploy, which could be name and location for the resource group. For the virtual network, it would be the name, the location, and the virtual subnet IP address range, and so on. So obviously you still need to know the cloud platform before you're capable of actually creating the template files. So from here, assuming that we have our template file up and running, the authoring part is done, we're gonna move to the deployment. And this is really one of the core slides in the whole session that I actually love. And the reason why is because it's really that easy. You start with Terraform init. It's one command that runs the initialization, validating if your template file is okay, validating what kind of target environment you want to use for your deployments, and importing all the binaries. Next to that, it allows you to run a Terraform plan, and it's allowing you to validate the template state, but also giving you a view on what actually will get deployed, or if it's an already existing deployment, telling you what will be changed. Changes, updating configurations, removing resources, or adding resources. And then last, the actual deployment is triggered using Terraform apply. That's the command we're going to use. And if needed, we can easily destroy the individual resources or the full resource group by running Terraform destroy. So it's really all you need to know to become an expert in Terraform. And yes, only 4 commands. Now, Terraform by itself is not limited to those 4, but that's all you need to know to get started. So from here, I'm going to walk you through some demos and showing you the different characteristics. So the first one, again, Terraform init allows you to initialize what we call the working directory. So you can store your template files in one single folder per project, per deployment, per resource type if you want. And from there, you're going to initialize the provider. And as you can see in the screenshot, we're obviously targeting Azure Resource Manager. Now, since Terraform is quite dynamic, similar to public cloud in general, it might be that some of your cloud providers need to be updated. Every now and then, similar to the challenge with ARM template API versions, it might break your deployments. So similar to the concept, you can hard code what kind of Terraform Azure resource provider you want to use, where in this case, I'm using the tilde larger than 1.2, which means that I'm using one of the latest versions, since I've been using Terraform for the last 3 years almost, where some of my initial Terraform templates, I'm actually still using them today, but every now and then I need to make some minor updates. So if you want to avoid any of those issues, you can hard code the version that you want to use before the template can actually run. And that should be a demo. There we go. So the only thing you need is terraform.exe. So in my working folder here, I have all my templates. Typically, you would store them somewhere in a shared location. If you're using a DevOps concept, you could store them in like an Azure shared storage, or what I'll show you later on, why not inside Azure repos. This terraform.exe 83 megs in size, that's my core Terraform tool. So I don't need any complex integration. I don't need VS Code for the deployment, although technically you could running some extensions. You don't need Visual Studio. It's just downloading terraform.exe, runs on Windows, Mac, and Linux, and from there you get started. So I talked about Terraform init, plan, apply, destroy, but again, technically you can do quite a lot of other stuff. So you can interact with the console, you can define environmental workspace if you want to deploy some templates against a dev and test environment and reapplying some of the concepts, but not all of them. You could move to different workspaces. Creating visual graph from Terraform resources, it's another interesting one where just instead of going through the actual syntax of a template, why not moving to some kind of visual representation? Storing credentials up here with Terraform login logout would be another interesting one. And listing up all the providers that are part of your configuration. From here, again, got a couple of examples. So let me open up the first one where up here I could do Terraform deploy. And that's the same file I used before to deploy my resource group. Now, I'm not going to bore you with just deploying a resource group. I'm going to switch to my second deployment where I'm going to run a virtual machine deployment. Now, as you can figure out here, it's a Windows VM. And every now and then it's like, oh yeah, of course, it's a Microsoft FTE talking, so it must be Windows. So to keep the open source model a little bit friendly, I'm going to use Linux VM deployment. Obviously, because Azure supports Linux VMs as well, and I hope that's not really a surprise for all of you. So what we're going to do here is switching to my Linux VM and running Terraform init. So what it's going to do here is initializing a plugin. So out of my Terraform file, let me switch back while it's downloading. Up here, I'm specifying that for deployment, I'm going to use the Azure RM provider. And next to that, I'm going to use the latest version. So anything that's above version 2.0, which got updated only a few weeks ago. So it's going to grab all the information, reaching out to HashiCorp, grabbing the versions 2.up. Where next to that, it's also installing some HashiCorp providers, so a random one and TLS that we're going to use for the encrypted connection towards Azure. Where now from here, it tells me Terraform has been successfully initialized, and it means we're ready to move on. Where it's telling us you need to use Terraform plan. Now, before doing that, let me show you what happened from a filing perspective. So within my application or my template folder, my first Linux VM, it created the .terraform 4.36. That's my local time here in Belgium. And it's going to install all the plugins directly coming from HashiCorp. So the nice thing is that imagine that again, you have a mixed environment, you have some older templates, you want to move to some newer ones, that there's not just one single Terraform environment. So there's one Terraform.exe, that's like the engine that's going to run it, but nothing would stop me from having one of my older templates here where it's using an older Terraform plugin. So each and every deployment folder is technically a workspace by itself. So now we know that the Azure provider got imported on our local machine inside that template folder, and we can move on with the Terraform plan, again allowing us to validate what we're actually going to deploy, confirming that the configuration is correct, and allowing us to validate what the Terraform steps will actually apply once we push the button. So back to my command prompt, running the planning phase. So from here, it's refreshing Terraform state. And again, I'll talk about the state itself in the next couple of minutes. So what happens now is that it's going to scan my Terraform file, my template definition, mapping it with the Azure provider, and from there listing up what's going to happen out of this deployment. Now, as you can see, it's reading out all the resources and all the resource settings. And for each and one of them, since it's a new deployment, let me go all the way up. It's scanning the file and it will tell me Terraform is going to perform the following actions, where any green plus sign means I'm going to deploy it. So I'm going to create a Linux virtual machine with all these settings. I can quickly read through, like, this is my local admin account. That's a computer name. It's in East US. My VM name, and so on and so on. I'm using the DS2, some operating system settings, and again, it's all almost plain English. Everything looks good, and in total, out of the planning stage, we're gonna add 11 resources. So think of the virtual machine resource, underlying virtual network, subnet, storage account, public IP address, and so on. So that's where the 11 Azure resources are coming from. So last, we're going to push the deploy button and running Terraform apply, where once more, it's going to list up all the changes. And technically, you could add a parameter like a auto confirm, where it's not going to ask you once more, like this is, again, what I'm going to do. On the other side, if you don't go through the Terraform plan state because you're using it over and over, it's still going to run through it in the backend. So it's never running anything without validating what's going to happen, without validating if the syntax is okay. And from here, you confirm, and it's already running. So again, think back about one of the other statements, that it's actually quite fast. Most of the time, it's actually my Azure portal running behind. So it means if I go back, open up my resource groups, there should be my first resource group. It's not showing up here yet. So I can refresh a couple of times. It's not updating, but up here it's already running. And in the meantime, it already created the resource group, the public IP that's happening here, creating the network security group. So let's see if my Azure portal is a bit supportive. There we go. My first Terraform deployment, and the resources are slightly showing up here, where again, in the backend, it's already a little bit further out. So I'll keep this running for now. Linux deployment on Azure shouldn't take that long. It's typically within a minute nowadays. Windows machine is still taking about 2 minutes. It's mainly because the operating system is a little bit heavier. That was the plan and apply state. It's nicely running. Where during my deployment, it's creating a state file. Now, what is the state file? It's literally, I would say, the intelligence, the brain of your Terraform, specific Terraform deployment, where in this case, what it creates is a JSON file. I know I told you I don't really like JSON, but it's what I need to use. But not going to use it for altering my template deployment, but I'm using it for my reporting. So if I switch back to my Linux VM, I now have my Terraform TF state file. And come on, it cannot open because my deployment is probably still running. There we go. So I'm a little bit too fast. Azure is still busy on a Saturday afternoon, but nothing wrong with that. Let's see if I have one from a previous deployment. I don't for now, so I'll keep it running and I'll get back to this in the next minute. But it's a quite cool concept. Now, what's even more interesting is that you can combine the best of both worlds. Now, what do I mean by that is that you can integrate Terraform, you can run it directly from Azure Cloud Shell, where for the ones who are a bit familiar with Azure, if you want to run it on from your local machine, you need to install the Terraform, you need to install the PowerShell Azure modules, or you need to install Azure CLI. Where next you could ask like, yeah, but how do I get my Terraform.exe into a Cloud Shell? The good news is you don't have to manage it because Azure Cloud Shell already has Terraform baked in. The other nice part that brings the two worlds together is that you can deploy an ARM template using Terraform syntax. So the use case there would be that, for example, you've been using Azure templates for the last 5 years, where now after this session you go like, oh my God, Terraform is so cool. I'm going to start using Terraform, but I don't want to rebuild my 500 ARM templates from the past. Or a second scenario where you might have some Azure resources like brand new, where the Terraform Azure provider is not aware about the new resource yet, where you're going to build a Terraform file or you're going to reuse the Terraform file you have. And from there, you can integrate your ARM template, a full template, or a snippet of a template where you just want to deploy that one specific resource that Terraform doesn't recognize, or integrating with Azure DevOps. So I'll show you that combination of Terraform syntax together with ARM syntax, where in meantime, my deployment is finished, which means that if all goes fine, I can now open up my Terraform state. Now, what's the idea with the state file? It's literally, I would say, a logging, a dump of your actual Azure deployment state. So in here, it's going to list up the authentication. So I created TLS key for my Linux machine, although I could use a local admin account as well. It has my user account in there, all information about my virtual machine, my operating system disk. So it's not a replacement for the Terraform deploy file, the skeleton file, but you can easily use this in your inventory if you want to find out like what's going on. Now, next to that, imagine that we're going to make a change to our deployment. So I'm going to make it easy and, for example, changing my VM size. I could change IP ranges and everything, but that's looking for trouble, not a Terraform dependency, but mainly an Azure dependency. So let's switch to another virtual machine size where the resizing is supported. So changing it, I save the file back to my Terraform. I don't need to run init anymore because nothing's really changing. So I'm going to run a new Terraform plan. So what's happening right now is that Terraform is now looking in the state of the deployment, where before, when I started, there was no state file, so it needed to create one. Where now it's going to validate that existing state file and reusing the state file, mapping it with the template definition and applying all the changes. So it's going to read out the virtual machine, subnet, network component, storage accounts, and then a little bit more towards the end, it's going to run some intelligence and telling me that this is the change we're going to make for you. Come on, Terraform, you can do this. There we go. So what happens here, it's listing up a change. So remember in the first deployment, it was a green plus, emphasizing it was adding something. Where now it's recognizing that it's going to run an update. What will be updated? Everything that's flagged with that orange/yellow tilde. So I just need to scroll down a little bit and I can easily identify up here. That's the change. Next to that, it's literally telling me this is my current state, the DS2, and I'm going to switch it to a DS4. So let's give it another push. And I forgot the auto acceptance, so now I need to wait and type yes once more. In the meantime, I'm checking the chat box for any questions. Looks all good besides contact details. I'll show them again all the way at the end in one of my last slides. But it's petender@microsoft.com. And if you want to follow me on Twitter, it's PDTIT. Come on, come on. I should learn and just deploy a storage account or something, but feedback from previous sessions was that, yeah, it's a too basic demo, so why not deploying a full VM? And I'm like, yeah, fine, but demos will take a little bit longer.
Peter, there's a question here.
Oh, okay.
Which from Vivek asking for debugging, can we derive an ARM template or REST APIs called out of the Terraform file?
No, that's not really a possibility. Now, what you can do, though, is imagine that you already have Azure resources deployed, because, again, you're here to learn about Terraform, where hopefully now you go like, oh, my God, this is so cool. But what about my existing resources? Because, again, the Terraform concept is hugely based on the Terraform state, where now you don't have the state file. So there's another comment called Terraform import. And what it allows you to do is recognizing the resource group, where you're just going to point, like you can see here. So once you grab your existing resource identifier, you go into the resource group, grab the properties, and that allows you to recognize all the resources inside the resource group and creating a new state file, even if the deployment itself didn't happen out of Terraform. But doing the opposite for debugging, for example, distilling like an ARM template out of a Terraform script, that wouldn't work. So this is in meantime again updating. So let me switch to my other example. So what I did here is again similar. The first part, interact with Azure RM, create a resource group. We're now in line 14. I'm running a new resource called Azure RM template deployment. Everything from line 20 all the way to line 60, well, line 70 if you want, is 100% storage account deployment from an ARM template. So this could be virtual machines, web apps, I mean, anything you can deploy using an ARM template. You go to GitHub, you grab an ARM template sample, and you can integrate it in your Terraform environment. And we do have a few minutes left, so let me show you how it runs. While this is running, I don't have to worry about it. Next to that, I don't need to run my command prompt in admin mode. It's all running locally, or even better, if you want, you could run PowerShell and do the same. Or if you're running the Microsoft terminal or Windows terminal, you can integrate it there. So from here, I could do the exact same thing. Go to Terraform, ARM sample. Again, running my Terraform in it. It's done. If I can forget about plan, because I need to speed it up a little bit.
You have a little more than 5 minutes, okay, Peter?
Yeah, fine. Perfectly on time, I guess. Just want to show you that it's not just possible in a VS Code template file, but it's actually running in real life as well. So as you can see, I don't need to go through that plan state. Once I go through my apply, it's still gonna use the same flow, the same concept, and somehow speeding up the process a little bit. So this one is running perfectly cool. Let me check back in my virtual machine where we switched to a different virtual machine size. A refresh my virtual machine, and it's a DS4 in meantime, where obviously before it was DS2. Good. Last part where Azure and Terraform are nicely working together is inside your DevOps process. Now I'm using Azure DevOps probably for obvious reasons, but if you have Jenkins, if you use TeamCity, if you use another DevOps tool, knowing that it can pick up terraform.exe, you can easily automate it. Even again, back to like creating a little PowerShell script where you're going to specify run Terraform init, Terraform plan, Terraform apply, squeeze all that in a little PowerShell script, and you're already running in a DevOps concept. So what it means if you're a little bit into CI/CD pipelines, you're going to start with your source code, in this case, your Terraform file. Next to that, I'm going to show you how to deploy, for example, a web app. And it's again using the same 3 steps, where now you're going to build your pipeline and running through the Terraform install, because the Azure DevOps build servers don't have Terraform by design. Or if you want to target a specific version, like I'm doing a version 12, if I remember correctly, where next it's again using that state file. Now, one side note here, once you move to a DevOps mode of working, you're not going to store the state file inside your deployment itself. Because for my local machine, all the demos that I did so far, it makes sense. I'm just the one running it. It's all on my local machine. But what if you're running this outside of a DevOps team where you have developers providing the templates, you have operations teams running the deployments? You're not going to store the state file on the local developer or operations machine. So what you can do is storing the state file, for example, in Azure Storage, storing it in an encrypted way, or moving to any of the other Terraform tools where Terraform Vault could be one of them. But since it's all Azure related, I would say my recommendation would be using it within an Azure storage account, using access keys, access policies, allowing you to lock down who can use the storage account location, because in the end, since that's where your state file is, it could contain some crucial information about your environment. So all goes fine. I have about 3 minutes left, I guess, and no new questions, so perfect timing. So what it looks like here is starting from your development environment, Visual Studio, integrating with your source control, could be Git, could be Azure repos, could be GitHub, could be Bitbucket, any other source control you're using. From there, moving, integrating with Terraform and pushing out your deployments. Azure VMs, web apps, storage accounts, I mean, anything you can deploy in Azure. And from there, obviously, monitoring it, managing it. That would be the ops part in DevOps, updating templates and repeating the same process. So for my last demo, I'm gonna quickly switch to my DevOps environment, where I got a little project called Terraform. What you need to do here is also creating an Azure service connection, obviously telling Azure DevOps, like this is the service principal you're going to use to deploy Terraform, where before in my local command box, I was already pre-authenticated. I got my source control, so I have my Terraform template file up here. I can make changes. I can integrate with VS Code, source control, checking in, committing changes, pull requests, anything you might know from DevOps way of working. And next, I also have my web app itself, allowing me to deploy not just the web app service, but also pushing out the actual source code. So we're gonna move to the pipeline. There is a build pipeline here where I'm actually validating my source code, mainly the web app, not really the Terraform integration, but where I'm actually running my deployment is in Azure DevOps releases. And quickly showing you what the pipeline looks like. It's almost going through a step-by-step process. So what I'm doing here, just to show you how nice it integrates with everything else on the Azure platform. So although I showed you that you can create a resource group out of Terraform templates, I'm showing you Azure CLI. So what I'm doing here on the side is running step 1 in my pipeline deployment to create my resource group and create a storage account. That's what's happening here. Then next, integrating, for example, Azure PowerShell, where I'm going to read out, let's make it a little bit bigger, reading out my storage account key, because that's what I need later on to interact with Terraform. Then running my variable updates. Now, the way it works within my pipeline, I predefined a couple of variables like my app service name, the service plan for my web app, and the storage account. So I'm not really hard coding them in the pipeline itself up here, but literally picking up from the variables. Next, I'm installing Terraform version 12, although on my local machine, I'm using version 13 in the meantime. And up here, most interesting, Terraform init plan apply, where this 3 steps will happen against my build servers. And once my web app resource is deployed out of Terraform, the last step is pick up this zip web deploy package and push it out into that Terraform resource you deployed. So quickly from here, and then I'm going to nicely close down where my release is running and giving it one last minute where hopefully I can show you that the build server is picking it up. There we go, in progress. Just want to show you that it's downloading Terraform and running through the different states. And it's moving. Cool. I'm going to close with grace within the last 40 seconds if my timing is correct. So I showed you that demo. So back to what I showed you in the last 60 minutes. So we started a long time ago, a little bit on infrastructure as code ARM templates, talked about what is Terraform and how it fits within the rest of the HashiCorp tooling, the basics, Terraform, init, plan, apply, destroy, integrating the best of both worlds using ARM template syntax in a Terraform world, or deploying Terraform templates directly from within the Cloud Shell. It's 100% the same. You upload your Terraform files or the folder in your Cloud Shell, and from there you run Terraform in it, and you're ready to go. And then closing with Azure DevOps. There's no outstanding question in my opinion, so I would say from my side, obrigado, and enjoy the rest of the sessions. Thank you so much.
Thanks a lot, Peter. Thank you for your session. It was a great session. I will now just pull in the video for the next session, and then we'll start right over. Okay. Thank you very much, Peter.
Thank you.